Hello, my dear students. This is Dr. Mohga, and today we're going to be talking about the center of gravity. Let's start. In this lesson, we're going to cover a couple of things. We're going to talk about the meaning of center of gravity, describe an experiment to determine the position of the center of gravity of an irregularly shaped plane lamina, and we're going to describe qualitatively the effect of the position of the center of gravity on the stability of simple objects. What's the meaning of center of gravity? The center of gravity of an object is the point at which the entire weight of the object may be considered to act. So it's also referred to as the center of mass when the gravitational field is uniform. The position of the center of gravity depends on two things: the shape and the distribution of mass within the object. So, for a regular symmetrical object with uniform density, the center of gravity lies at the geometric center. For example, if I have a square, then the center of gravity will be right in the middle. If I have a circle, then right in the center of my circle will be the center of gravity. But for an irregular object, the center of gravity may be found by an experiment using the plumb line method, which is very, very easy. What you need to do is that you're going to do the following steps to find where is the center of gravity so that this object will have to be perfectly balanced and remain at rest. Now, where is the center of gravity of a uniform 1 meter wooden rule? This is a regular object. Like we said, it's right in the middle, so it's going to be exactly at 50 centimeter mark, which is midpoint. So how do we find the center of gravity for an irregular object? To find the point through which the entire weight of an irregularly shaped flat object lamina acts, its center of gravity, we need to get an irregular cardboard or plastic lamina with holes near the edges, clamp stand with a boson pin or nail, plumb line, which is a string with a small weight, and a pencil and ruler. Here's what we need to do. Number 1, you're going to hang the lamina freely from a hole near its edge using a pin or nail through the clamp stand, as you can see here. Of course, you're going to have to wait until it's completely at rest. And then you're going to hang the plumb line from the same pin in front of the lamina, pointing downwards. When both are steady, use a pencil and a ruler to draw this vertical line on the lamina that follows the string of the plumb line. You repeat the same steps by moving it around and trying all the different holes that are at the edges that you've created. Each time you're going to draw the same line. When you draw all the lines, eventually you're going to find that they're all intersecting at a certain point, and this is where your center of gravity is. So the point of intersection of all vertical lines is the only point where the lamina can be balanced horizontally. And this is the center of gravity of this irregular shape. Here's an example. Pause the video, try it on your own, and then unpause. A student cuts out an irregularly shaped cardboard piece and follows the above procedure. The 3 vertical lines drawn from different suspension points intersect at one spot inside the lamina. What does this tell you? It tells us that those intersecting points show us the center of gravity of the lamina. So if we balance the lamina on a pin at that exact point, it will remain balanced. Now let's talk a bit about stability. The stability of an object refers to how likely it is to return to its original position after being slightly disturbed or tilted. The position of the center of gravity plays a major role in determining the stability. If I have a low center of gravity, such as this example here, So I'll have greater stability. The object is less likely to topple over, and the wider base combined with a low center of gravity improves balance so much, such as what sports cars, and wide vases. However, look at the second picture. Here, the center of gravity is higher, which makes it less stable. So the object becomes heavy at the top part, which will mean it will be more likely to topple when tilted. And objects like double-decker buses and tall shelves are less stable and must be carefully designed accordingly. We also have narrow base and high center of gravity. Those are very unstable because any small disturbance can cause the vertical line through the center of gravity to fall outside the base, leading to toppling. Here's a visual rule. Looking at both blocks, which one do you think is more stable, having its bottom part completely settled on the floor or on the ground, with the center of gravity pointing down towards the ground? If the vertical line from the center of gravity falls within the base, as you can see here, the object will return to its original position, which means it's stable. If the vertical line from the center of gravity falls outside the base, then the object will topple, which will make it unstable. Here's an example. Compare the stability of a cone standing on its base and the same cone standing on its tip. Which will be more stable? Of course, cone on base has a low center of gravity and a wide base, so that's very stable. Cone on tip has high center of gravity and narrow base, that's very unstable, meaning that any disturbance will make it fall over. Thank you so much for watching. If you have any questions, leave them in the comments, and I'll see you next class.